Hello friends, myself Salil Gadgil. I am a mathematics teacher and I have also authored a couple of math workbooks. In this video, we are going to discuss the altitude of a triangle. I am going to show you how to construct it, all its properties, as well as I'll clear a few misconceptions related to it. Let's see how it is done. So in this particular segment, let's understand what an altitude is and let's also understand how to construct an altitude. So here I've drawn a triangle ABC. Take out your notebook, draw a triangle and construct the altitude along with me. So now what I'm going to do is I'm going to construct a line segment which is perpendicular to BC. Perpendicular means that line segment has to make a right angle with BC and it has to pass through the vertex A. So let's see how it's done. What I'll do is I'll take a suitable rounder measurement. Now by the term suitable I mean if I place my rounder over point A, okay, at this particular point, then I should be able to draw two different arcs on the line segment BC. So take any measurement, as long as you can draw those two different arcs, you're okay. So here I am drawing one arc which is intersecting BC at one point and this is the second arc. Okay, so using A as my center, using the rounder, I have constructed two arcs which are intersecting BC at two different points. Now what I do is I again change my rounder measurement, or I can also keep the same rounder measurement, but I am going to change the rounder measurement. After changing the rounder measurement, I draw two arcs from these 2 points. Okay, I can draw these two arcs either above the line segment or below the line segment, that doesn't matter. So again I have changed the rounder measurement. I am keeping the rounder on the first arc which I have drawn. I construct an arc. Okay, now I keep the same, using the same measurement, I keep the rounder on the other arc and I draw another arc. So these two arcs are now intersecting at this particular point. So now what I am going to do is I am going to join the vertex of the triangle with this particular point. So let's do that. So this is the point where the two arcs intersect. I am going to join the vertex of the triangle along with this particular point and extend it to the base. This particular line segment AX now forms the altitude of my triangle. If you actually take your protractor and measure this particular angle, it will be 90 degrees. So you can do that on your piece of paper and you can check if this particular angle is a right angle. If it's a right angle, then you have drawn the altitude in the correct way. Now there are three vertices in this triangle, so I can definitely construct three altitudes, one from each vertex. So if I construct the altitude from the point B using the same procedure, then I get this as my second altitude. Okay, so this particular line segment is also perpendicular to AC. So let me name this particular point as Y. So BY is perpendicular to AC, which is why it is the second altitude. The third altitude would also pass through the same point of intersection. So do you notice these two altitudes are meeting at this particular point? This particular point is called the orthocenter of your triangle. It is the point where the three altitudes meet. Okay, so the first conclusion is I can draw three altitudes in a triangle. The point where the altitudes meet, this particular point is called the orthocenter. Okay, now what is the significance of the altitude of the triangle? The altitude of the triangle is useful in measuring the area of the triangle. So we know that the area of a triangle is given by half into base multiplied by the height. So now this is a key concept, that if you consider BC to be your base, then AX would be your altitude. So let's write the combinations of base and height. The base and height of the triangle or base and altitude of the triangle always have to be perpendicular to each other. So if you consider BC to be the base, then if BC is the base, then AX is going to be the height. Okay, so area of the triangle would be half into BC into AX. Or if you consider AC to be your base, so if AC is the base, then which altitude is perpendicular to it? BY. So BY is the altitude. So the area of the triangle would also be half into AC into BY. Whereas if you consider AB as your base, so AB, if AB is your base, then which altitude is perpendicular to AB? Let's name this point as Z. CZ is your altitude. So this is one of the significances of altitudes. Altitudes are going to be useful in determining the area of your triangle. Now in the next segment, let's see how altitudes are placed in different types of triangles. So in this segment, we are interested in looking at the altitude of the triangle for the different types of triangles. We are interested in seeing the position of the orthocenter when it comes to acute angle triangles, right angle triangles and the obtuse angle triangle. We are also interested in seeing the relation between the altitudes, medians and angle bisectors for scalene triangles, isosceles triangles and equilateral triangles. So let's take the acute angle triangle first. In an acute angle triangle, altitude is basically the line segment that joins the